Hello friends, today we will cover some important components of number system. Although you are already aware about this subject, still for revision sake, I will take up this topic here. First we will see what are the natural numbers. What are the natural numbers? Natural numbers are the set of positive integers that are used for counting, ordering, and numbering. Counting numbers starting from 1 and goes on to infinity, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on up to the endless. Friends, if you can recall that a 2 or 3 years old kid tried to count the numbers, say about counting for toys, chocolates, or some toffees, he just know the numbers. He says 1, 2, 3, 4, 5, 6, 7, 8, up to the number which he could remember easily. He has no clue about zero. It implies that kid is stating about natural number. So going forward, natural numbers are usually denoted by the symbol n. N is a set of natural number 1, 2, 3, 4, 5, and so on up to the infinity. It does not include zero. Can you remember it? It does not include zero. What are the key characteristics of natural numbers? Countable. They are countable. They are used to count the objects, like 5 chairs in a room, 10 boys in a classroom, 50 rooms in a school, and etc. No fraction or decimal. They are not represented in the form of fraction or decimal. So I will give some example. Fraction 3 by 4 or 9 by 8. These are the fraction. They cannot be represented in the form of fraction or decimal. 2.54 or 0.69. They are non-negative numbers. What are non-negative numbers? -3, -10, -6, etc. But they are not the natural numbers. Okay. Mathematical operations. Mathematical operations like addition, subtraction, multiplication, and division can be performed by using the numbers. Measurement. They are used in measuring quantities like distance, weight, time, and temperature. How? Distance in, say, 20 kilometer, weight 200 gram, time 30 seconds, and temperature is 35 degrees Celsius. Labeling and identification. Labeling and for numbering of some houses like house number 44, row number 3, and phone number like 9898989898. Roll number of a student in classroom, just such as roll number 5. So these are the key characteristics of natural numbers. Going forward, we have another component of the system, which is a whole number. Whole number. Whole numbers are the set of numbers that start from 0 and go on indefinitely, like natural numbers. 0, 1, 2, 3, 4, and so on. And as it means they include natural number, which begins from 1, but also include 0. They do not include negative numbers or fraction. Negative number like -3, -10, -1. So these are not included. And fraction 3/6 by type of, they are also not included. What is the concept of whole number in mathematics? Whole numbers are a fundamental part of a mathematics used in counting, ordering, and various arithmetic operations like natural number. They are the part of the number system that helps define numerical relationship and patterns. Moving forward, we will now talk about an essential component of number system, which is called integer. The integer is an extended whole number that can be positive, negative, or zero, but it does not include fractions or decimals. Set of integers. The set of integers is represented as z, which is shown here. I would like to add some interesting fact here that the notation z comes from the German word Zahlen, which means numbers. Moving further, positive integers are 1, 2, 3, 4. These are the right side of the 0, 1, 2, 3, 4, and so on. Negative integers are -1, -2, -3, -4, which are falling left of the 0. 0 is neither positive nor negative. Integers are placed on a horizontal number line with 0 at the center. You can see here. Positive integers are to the right side of the 0. These are the positive integers. Negative integers are towards left of 0. -1, -2, -3, -4, and so on. Now we will discuss about the key properties of the integers. No fractions or decimals. Again, like natural number, it cannot be represented in the form of fractions and decimals. Integers extend infinitely in both positive and negative direction. Every integer has a next successor and previous predecessor. For example, if we take number 1, its successor will be 2 and predecessor will be 0. And if we take the example of -2, its successor will be -1 and predecessor will be -3. This helps visualize operations like addition, subtraction, and comparison. Mathematical representation in the form of set notation Z, and addition, subtractions can be performed like this. -3 is added with 5, will become 2. Multiplication, -2 is multiplied by 3, will become -6. 12 divided by -3 will become -4. And in real world representations, how we apply these integers? For calculating temperature, I will give an example. Suppose at noon, Shimla's temperature was 5 degrees Celsius and it dropped by 6 degrees Celsius by evening. How much was the resultant temperature at evening? So let us calculate. 5 minus 6 degree is equal to -1. So resultant temperature will be -1 degree Celsius. In the case of bank balance, suppose a person has only 2,000 rupees in their account, but withdraws 3,000 rupees. Now the balance has become -1,000, meaning they owe the bank rupees 1,000 rupees. And again, if they deposit 2,000 later on, the new balance would be 1,000 rupees. So this way integers are being used Or for calculating elevations, a mountain peak is 2,500 meters above the sea level, meaning it is 2,500 meters above the sea level. And on the other hand, the Dead Sea, one of the lowest point on Earth, has an elevation of 430 meters, minus 430 meters. Minus 430 meters, it means that this Dead Sea lowest point is 430 meters below the mean sea level. So this is the way how we calculate integers. And friends, this is all about for this topic for the day. And if you like and if you understand that this video was useful for you, you can subscribe my channel and like, share, and if you have any comment, you can comment on the comment box. Thank you very much. Thank you for watching.